From the previous lecture, you already know what Newton's first law of motion is. Essentially, it says that objects keep on doing what they are doing unless there is an unbalanced force acting on it. In this video, I'm going to introduce Newton's second law. Imagine you have a block of ice on floor. Okay, I'm going to consider this is an ice flow so that there is no friction between those. So there will be two forces acting on these blocks. There's a force downward called weight, and then there's a supporting force from the ground called normal force. And this normal force is upward. But these forces are balanced. That means they are equal and opposite, creating a balanced force pair. Because of that reason, this block would not and will not move. Because this block is on ice, you can imagine that there is very little friction or no friction between those two blocks. So we can just assume that there is no friction at all. Now imagine if you want to move this block, we need to apply an unbalanced force, because balanced forces would not create motion. We need to have unbalanced force. What we can do is we can just push these blocks to the right like this. So I'm going to create a pushing force to the right. Now this pushing force is unbalanced because there is no other force to balance it. Therefore the object will start to move to the right. That means object really changing its velocity from 0 to something. So it's going to move to the right. And when it moves right there, it will have some kind of velocity. That means object is really changing its velocity from 0 to something, means that it is accelerating. So essentially, unbalanced forces are the reasons for acceleration. If you have more than one unbalanced forces, however, all of these forces are responsible for producing acceleration. Therefore, we introduce a new term called net force. It is the combination of all the forces acting on the object. So net force. It turns out that if you want to increase the acceleration of an object, you need to increase the net force. If you double the pushing force, the acceleration will double. If you triple the net force, the acceleration will triple. So Newton found that the acceleration of an object is directly proportional to the net force you are applying. So you can write it something like this. Acceleration is directly proportional. This symbol represents the direct proportionality, and it's proportional to the net force. But Newton also noticed that there's another physical quantity that affecting the acceleration of an object, which is none other than the mass. It turns out that if you double the mass, keeping the same force, the acceleration became half of the previous acceleration. Now you double the mass, acceleration became half. And if you triple the mass, the acceleration became 1/3 of the previous acceleration. Therefore, Newton decided that acceleration is inversely proportional to the mass. So let me write this down. Acceleration is inversely proportional to the mass. This inverse proportionality is the 1 divided by mass. That means if you increase the mass, acceleration is actually decreasing. Double the mass, acceleration became half. So other than these two observations, he also noticed that the direction of the acceleration is exactly the same as the direction of the net force. So the direction of the acceleration exactly same as the direction of the net force. Alright, combining these three results, he came up with Newton's second law of motion. The acceleration of an object is directly proportional to the net force acting on it, and it is inversely proportional to the mass. The direction of the acceleration is the direction of the net force acting on the object. Now we can write an equation for Newton's second law. The acceleration I am going to make as A, and the net force I'm going to give a symbol like sigma F, which is the sum of the forces, net force. And then the mass I'm going to give the symbol M. Now if you combine these things, acceleration is directly proportional to the net force, acceleration is inversely net force, acceleration is inversely proportional to the mass. You combine these two, the acceleration is equal to the force divided by m. I'm going to consider the proportionality constant as 1. So, multiply both sides by m. Then that means that net force is equal to mass times acceleration. And this will be your Newton's second law of motion as an equation. In next few lessons, we are going to learn how to use this equation to do calculations. Stay tuned.